Okay, so in this video, we're going to start looking at statistical reports, and we're going to be looking at the margin of error, or MOE. Okay, so it's a bit of a misnomer in its name because it's not actually measuring errors. It's measuring the sample variability, which we've talked about in other standards. We talked about it in statistical inference at level 2, and we talked about it particularly at inference at level 3. But, you know, there's still this idea that there are errors, and actually the process of taking a sample means that every time I take a sample, I'm going to get slightly different answers. And that's what my margin of error is measuring. It's measuring how much variability I expect to happen in a sample when I've conducted the sample and found my results. That's not to be confused with non-sampling errors in statistical reports, which are the ones that I have caused by doing really bad statistics and collecting bad data and not thinking about my sampling process and choosing a not representative sample and allowing people to answer with I don't know or undecided, or me having written really poor questions. All of those things will be classed as non-sampling errors. Okay, now we have two different formulas to worry about in this margin of error calculation. We have the rule of thumb, and we have the traditional central limit theorem based margin of error calculation, which also uses a number that's gained from the normal distribution, because when I sample a bunch of means and I work out the mean of means, I expect that to be normally distributed, even if the original distribution isn't normal, which is where that comes from. So there's quite a lot to worry about, but let's just get on and start focusing on a few of the simpler bits. So, the rule of thumb. So the rule of thumb is that if you have a proportion that is between 30% and 70%, I don't have to use a really complicated formula. I can just use that the margin of error is 1 divided by the square root of the sample size. Whereas if my percentage is smaller than 30% or larger than 70%, then I have to use the formula that is a little bit more complicated, and it is 1.96 times the square root of p times 1 minus p over n. Now, these two equations are linked, because if I do some simplifications, I make p a half, and I say 1.96 is so close to 2, I might as well treat it as 2, then this formula becomes that formula. So that's what's going on there. And one of the key things is, if I assume that p is a half, that's why it only works between 30 and 70%. So that's what's going on there. So what I've done is I've found a statement about New Zealand's last general election, which was in 2017. And I've got that National and Labour were on about 46 and 37%, and the Greens were on about 8%. I know these percentages don't add up to 100% because I didn't bother carrying with anyone who wasn't likely to get above the 5% threshold, which is a key part of the New Zealand MMP. Okay, but say I want to work out the percentage that national, or the margin of error for national. So I would go the margin of error for national. Well, that national are on 46%. So therefore, I don't have to worry about them being below 30% or above 70% because I know they're above, I know they're in that sweet spot. So therefore, I know the margin of error is just going to be 1 divided by the square root of 1750. Now that as a decimal is going to give me 0.0239. We know that we generally want margin of errors to be written as percentages, and to convert percentages to, or decimal to percentages, we know that we just multiply by 100. So my percentage is 2.4%. So the margin of error for the national vote is 2.4%. We'll come to in the next video about what that actually means and constructing a confidence interval, but that's all I wanted to do for this one. Whereas if I'm going to get a different highlight color, because they're the greens, I'm going to choose green. The Green Party was likely to get 8%. So when I come to work out the margin of error of the Green Party, my challenge is that I know their proportion is smaller than 100%. Sorry, smaller than 30%. So their proportion is 8%, which is 0.08. So I've got to be able to convert from decimals to percentages and back again really easily in this. So therefore, their margin of error is going to be 1.96 times the square root of 0.08 times 1 minus 0.08 over the 1750, and now I've written all the rest of the calculation. I can do my square root, and that is going to be, give me a value that is going to be smaller than the national one. So my answer is 0.0127, which is 1.27%. And that kind of makes sense, because if you've got a party which has got a smaller population base, a smaller group of people that are likely to vote for it, then their margin of error is likely to end up being smaller. It's kind of logical. So I've worked out that the margin of error of Greens is 1.25. Of course, margin of error for New Zealand First is likely to be smaller still because their percentage is smaller. And the margin of error for National and Labour, because they're both in that 30 to 70%, is about 2.4%. So when you sometimes see them talking about opinion polls in the news, particularly as we're gearing up for a general election, and they're saying that the percentages are these and the margin of error is, that margin of error is only going to be the one that's working for the biggest parties. The margin of error for the smaller parties, with a smaller support, is likely to be lower. Okay, so that's what I'm trying to get across with the margin of error. That's the actual calculation. And we've covered the two main calculations, the margin of error rule of thumb, and the margin of error when you've got a percentage smaller than 30 or bigger than 70%. I hope that kind of makes sense. The next video is going to be about constructing a confidence interval and then starting to look at, differences. Okay, so until next time.